everybody. Hello, every Java developer. How are you guys? I'm really glad to be with you here. And I would really welcome warmly our speaker today is a very unique speaker, is a Java champion, also is a Jakarta EE ambassador. He's also a software engineer for more than a decade, and he's really putting too much effort and impact on the Java community. He's based in Toronto, Canada. Let me introduce Bazl Rahman. Hi, Bazl. How are you? Glad to be with
Assalamu
you here.
alaikum, everyone.
Alaikum salam wa rahmatullahi wa barakatuh. How are you, brother? Good. So
Doing
just let
great.
me give you a quick overview about our Riyadh Java user group is a newly established Java user group focusing on growing our Java skills and learning together and trying to trying to put so many, trying to our best to impact the Java community and trying to also to host worldwide speakers, local speakers. Everybody is welcome here. So today we're going to talk about a very interesting topic about breaking the stereotypes of the Java. So let's welcome our speaker, Basler. Mike is yours.
Thank you very much. And thank you for introducing me to your audience. And hopefully, so the topic is, title should be sounds like catchy one. But yeah, the idea is basically I'm going to go to sharing some of the overview of recent development of the Java, which are pretty exciting, especially to me. So I'm enjoying this new advancement of Java. So that's what I'm going to share with you all. So before I share, what are the recent Java features, I would like to know what version of Java you guys are using in your production system. So if you're watching, hearing, listening to me, can you comments on the platform that you are watching from, and basically type what version of Java you guys are using, so that I get a sense of uh, your situation basically. So yeah, so let's go ahead, moving on. So yeah, first of all, I mean, this sounds like the slides, as you can see. I'm gonna deal with a stereotype first of all, which is there is a common stereotype in the wider community of software engineering, I would say. Software development is, which is basically, some people still believe that Java is complex, verbose, and and it's a legacy. So programming language, it's been a while. It's rigid, it's difficult to write codes, I have to write a lot of codes. Um, and in fact, let me tell you a story. Well, I was I was in a flight, coming from Zurich to Toronto, and a guy, we were discussing about this similar topics. He asked me what I do, and obviously I was enthusiastic about sharing my journey, and I said that I'm a Java developer, and he basically, surprised. You still use Java? I mean, I used to. He was saying, like, I used to do Java like 20 years back, and I didn't like it. So I tried to explain that, the Java that you used to 20 years ago is not the same Java that we are using. It's much more fun. It's way less verbose, and it's efficient. It's extremely productive and all those things. But yeah, it was difficult to explain that because he probably didn't touch Java for in last 10 years. So what happens is, in last 10 years, Java really improved a lot. A lot of interesting features came into the JDK, which we are currently using. For example, I'm always a big fan of using the latest JDK. Currently I'm using JDK 21, and last month, in recently, I think last month, um, uh, JDK 20 2 was released, and it had also a numerous features. I would say among many features, 21 is probably the most significant release, I would say, in recent past since JDK 28. So I'm super excited about that. So let's go ahead and see some of those features, and I hope once we see all of those features, if you have that kind of mindset, it will change your mind. And if you do so, let us know in the comment. So let's go ahead to the next slides. All right. As I can, I mean, this slide is not redundant. I mean, I already said all of those things. New language features really streamlined syntax, emphasis on data handling and expressiveness. And there's nothing to say about performance and concurrency optimization. I mean, every uh, updates of JDK, every new release improves tons of features, including performance, and some of those are hidden from a developers. We don't even see those changes. Basically, we get performance from nowhere. I mean, let's say I am using JDK 8, and then I just migrated my application to JDK 11. I have received a lot of free performance out of the box, and I didn't have to do anything. So those kind of things happens regularly, and as a developer, you sometimes take it granted. So those are happening, and one of the biggest one is definitely concurrency, which is virtual thread. I'll talk a little bit about that as well in this talk in end of the sections. So stay with me. All right. So the first one is probably the legendary one. I must, I'm pretty sure those who are started learning Java when you were first undergrad or somewhere where you started learning program, and your instructor asked you to write this program, right? Public class main, and then something like public static void main. Inside a bracket you used string, and then two square bracket and something like args, and then you write some codes. So the problem with this code, it's simple. It just prints something, say hello words. The problem with this code is it's too ceremonial, right? To achieve certain things, you have to do a lot of work first. And as a beginner, you probably don't even understand any of those things. So if you ask those questions, like, to your instructor, what does static mean? What does void mean? Um, your question is legitimate, but problem is your instructor will not be able to answer immediately, because to understand those topic, you have to at least understand some of the other stuff which you haven't explored yet, right? So they would say, wait, just memorize this. We'll discuss this 6 months later or 3 months later. That's definitely frustrating, right, for a beginner programmers. So finally, after like 27 years later, Java is finally tackling this issue. So let's make it simplified it. I'm super happy, because something is better than late never, right? Better late than never. So it's happening. All right. So what you can see over here is, if you want to run a program like say hello, you just want to stick to that particular things. So over here, public static stringers, those are probably doesn't make any sense, right? So maybe we skip those things, and that's what is called flexible main methods, and Java introduced that. It's available. In So if you use JDK 21, you have to use preview feature. Probably JDK 22, you don't have to. I'm not quite sure, but we can see that. So basically, now you don't have to add any static, an argument. You can just write a main method like void main. I'm going to show you demo. And even if you don't want to put the class structure, that's also fine. You can just write. You can create a file, and then you just write a function like main, and then if you want to do a print method, it will work out of the box. So that's what actually called flexible main method. I'm pretty sure this is going to help the beginner students to to start their programming without a lot of questions. So they will be able to follow immediately. So let me show you an examples over here. I have already created a simple program. As you can see, it's a file. I've created a main class, and it doesn't have any structure over here, right? I mean, it doesn't have any class structure. So you can immediately write program something like that. So void main, and then you can do a main method call, or you can say simply, you know, let's say I want to write the system out println, and there is a reference over here. But if I don't need that, I can just do inline, and if I want to run it, it will definitely run. As you can see, it says hello world. So yeah, I mean, this is exciting. I loved it, and I used to teach a university for a while, and I had this question always. I mean, what does this mean? It had gave me immense hard time to explain the beginner student how to start a Java program. Now, hopefully, if I want to teach again, this is going to solve my all problem. So yeah, and you can write a lot of code over here. Like, you can write a function. I mean, if I just undo everything, like over here I have created a function, and you can call this function inside from the main method. And if you have a field, you can definitely declare field over on top. So you can also access those fields from any of those methods. So yeah, so that's what flexible main method looks like, and I'm super happy about that. Finally, it's here in Java. Compared to other languages, people really love other programming languages, especially Python, because they have a simpler way to start. Now Java has it, so the construct, the comparison is going to be a different now. All right, moving on. There is another tip which is I'm really excited about, which is efficient data representation. This is called record. So basically, how we represent data basically sits on the at the foundation of nearly every applications, right? I mean, Java has always prioritized robust data modeling, and now it's basically enhanced and streamlined with this new powerful feature called records. So it's basically a immutable data structure. We transfer data from one place to one place. Especially in the business application, we have to do a lot of data representation and then transfer one data from one layer to another layer, right? So we usually used to do something like, let me show you a demo rather than going into slides. So let's say this is a range class. What I'm going to do is I'm going to revert back. Let me see if I can revert back. Okay, sorry. This is not working for some reason, but let me try it again. Convert. Okay, so this is the way we used to do ideally. So we would write a class. Maybe let me make it final. Public. So we'll write a public class, and then we'd have a few fields. We'll have constructor. We'll have getter and setter. Over here, we can definitely generate getter setter using what do we say, IDE. But again, we have to implement those codes, and we have to carry those codes along with our source control system. So, I mean, what does this class really achieve? Basically, it has two fields, which is low and high, and we want to set those value once, and then we can so that we can carry over. But to achieve that, we had to go through a lot of ceremony, as usual, boilerplates. For example, constructor, getter and setter equals hash code, twisting, a lot of things. And with this with this record feature, we don't have to do any of those things. So basically, we declare, let me undo all of those things. So we just declare this is enough. Let me remove this one. So same thing, but it has all of those elements. For example, this we can definitely, over here you can see I have instantiate range over here, and I put a value 1 or 2, and I can use them anywhere, any way I want to. I can do a toString. I can call a hi, something like that, or we can. There is a method as well. I can call like this. So yeah, I mean, if we have another range, to sorry, that's not allowed yet, but hopefully there is a JEP where we can create a derivative range. It's going to be added in JDK 23. Let's hope for that. So new range. Now we can do compare, right? For example, is range 1 is equals range 2, right? I can do something like that, and without implementing any of equals and hash code. So those are fascinating features, and I really love them. And I've been using records pretty much in my production system. So if you are interested, you can definitely use them now. If of course you have to upgrade to JDK 21 at least. I think record is available way before 1021, so you can also. I forgot the version where records is available. It's probably 17. It's probably 17 or something like that. So if you have at least 17, you can use records, and it's super easier. And if you want to, do add a constructor, you can also add constructor over here. But it's concise. It's just less code, achieving the same thing with the huge amount of code we used to do. So less boilerplate, less verbose. All right. So here are some characteristics of records. Records are implicitly final, designed to be transparent carrier from immutable data, and we love immutable data because since JDK 8, we sort of we have introduced functional programming nature in our Java, right? And functional programming emphasize and immutable data that helps make databases in a safe manner. It's a thread safe, and lots of other benefits there. So records is final. Record is basically especially very useful for those scenarios. So yeah, there are some characteristics over here. Anyway, so the next feature that I would like to talk about, which is sync classes. But before going into that, let me know if you have any questions. I
Yes,
can
Basil.
definitely.
Yes,
Sorry.
Basil. So before going to this, I think Nabil is asking, is the main method come under the default object class, or if it's not defined in the defined class?
So we can definitely check that. So let's say if so let's say I have a main class right over here, uh, and I have not. I mean, I've created a file over here, and I haven't I haven't um, created a class over here. I didn't name anything. So if we compile that, I can see what it happens in basically. So let's see. This is the compiled version of right. So if I see over here, and as you can see, if I don't provide a class name, it's already added a class name over here. So yeah, and if I explicitly define a class, let's see what happens. Let's say I name it something like public class. Maybe let's not name it public because I haven't named the file is main. Let's say class hello world. Sorry. And I'm gonna put everything inside it. So now we still have main method over here, and I still run it. I still can compile it. And if I go over here now, where is my main? This is the hello world, right? Now basically, so this is the compiled version of Java. If I click on it, IDEA basically decompiled it what bytecode has. So this is a decompiled version of bytecode. We could just see using command line, but I thought, uh, since IDEA has this feature, we can just immediately use it. So if I provide it, it will use our class name. But if I don't provide it, it will just create with the name of file name that we are gonna provide it, basically. So I hope that answers your questions. Um,
Yes, that's awesome feature. So this feature is in Java 21 or Java 22?
Java 21, it's under preview feature. So basically, when you do it, you have to enable a preview feature like this. If you do a command line, then you have to do something like that. Let me clear my window over here. So what you have to do is you have to go into that class. I mean locations. Let me. It's probably under the source. Yeah. So let me go into that cd source. So Java main Java. If I run this, ls, I should have Java over here. Main confinement class. Probably okay. So basically, I have to provide so enable preview Java preview source. I'm running 23. That's why I'm giving 23. So now, as you can see, you have to provide these two flag to run it. So it's still under preview features. So make sure you do provide that. But if you use IntelliJ IDEA, you can basically configure that from here. So if you use JDK 23 and language level, it will automatically add. It will automatically enable this flag. But if you do command line, you definitely make sure you use this flag while you are compiling. For example, enable preview, and then you have to also provide the source. I'm currently running 23, so that's why I provided 23 on this machine. But if you are running 21, obviously we're going to provide 21. Anyway,
That's nice. Sounds good. Yeah, that's really good feature. So there is another question regarding the records. So someone is asking about, is records are immutable or they are mutable?
record are by default immutable. So once you create an instance, you cannot change it. And the purpose of data representation, for example, you want to pass data from one place to another place, one layer to another layer. It makes sense that you send the data in an immutable fashion, so that they cannot change it, right? The other layer cannot change it. And that's the whole idea. Basically, the idea is it's a dump data carrier. It's especially useful when you have a lot of data transfer object, like in our web applications or business application. We have a lot of data transfer object. We call it DTO, right? So those are the really useful cases. If you want to change it, then you have to create a new one. Basically, that's the idea. So you cannot change once you have created the records, and by default all the fields are final.
Also, the same question, is it like shallowly immutable or fully immutable?
That's a good question. We can basically try and see if that's the case. I It's probably only the field. I think so. Let's create a records and let's add a new field over here. So let's say I have a new field list of integers, right? Um, let's say values. I have installed GitHub Copilot, and it's super annoying. It's give me all sort of suggestions out of nowhere, which I probably don't want. Anyway, So let's create. Let's see. So um, I'm gonna probably not gonna use list of, because list of itself immutable. That will not help me with the test. So let me new, or maybe let's wrap it with a new array list. So now I definitely cannot change field, right? Um, right, I cannot do that because it's field are immutable. But let's see what if I can add um, another value over here. So if this works, that means that's you get the answers, right? So let's print it. Yeah, it's like so if we have a reference, that's basically the reference is final, but the content is not. Does that answer your questions?
Yeah, I think it does.
Thank you.
Yeah. So another question. Sorry, I think it's repeating always comparing the records with the Lombok framework. So is it replaceable, or we can use both, or what's your thought?
I mean, so if it is immutable data structure, Lombok probably not required. I mean, in many cases, we pretty much use this sort of data structure just to carry data. In those cases, Lombok is probably not required. But there are some cases, some scenario where records probably not suitable yet. For example, if you need to immutable data structure. So personally, it's how you are designing your systems. If you want to emphasize on immutable data structure, then record is probably way to go. But if you have applications of having immutable data structure, then that's the place where Lombok has some use cases. In our production environment, we have a lot of use cases of Lombok. So we didn't replace Lomboks with a record yet, but I feel like down the road, when record has more enhanced feature, for example, in JDK 23 there is a JEP they're introducing called derived record class. So basically, you can create with the existing value, and if you want to change certain value, you can create another records without changing the original one, um, with simpler syntax. That then it will help in those scenarios. So the fundamentally the answer is how you design your applications. So if you emphasize on immutable data structure, then records the way to go, but Lombok will stay for a while, I guess. So yeah, I mean, it's up to you. You can still use Lombok. I mean, we use Lombok for many cases. So I'm not saying they're going to replace each other. They have still use cases. I
Yeah.
mean, Lombok has some other features as well, so those are not available in here.
Yeah. Sure.
Oh, all right.
Uh,
So let's. I'm gonna move ahead a bit faster because I have a lot of things to cover, and we already spent like 30 minutes here on this initial, features. So I'm gonna go ahead a bit faster from now on. All right. So let's talk about the control inheritance with still class. So this is the one of the feature that I really love. The idea is the inheritance in Java is basically either you close the inheritance or you open it for entire world. So that's two way of doing inheritance in Java. So if you create an abstract class, or if you allow extending, anyone can extend a particular class. So now let's just have a scenario. Let me give you an example, uh, if I can. Sealed class example. So let's say you have an interface over here. interface is basically, let's say, greetings. So you have a method over here, public say. That's all. And now you have a method over here, void accept. So accept greetings, right? And you have a main method over here, let's say. Now a greetings definitely, if I were to use this method, accept, I have to have instance of greetings, right? And I can, I have, sorry, this is giving too much pain. Anyway, so let's say I have a class. So let's say over here, English greetings, and I have another class, uh, Arabic greetings, right? So I can decide which one I want to pass. Accept new Arabic greetings, right? So but the problem is, since this is allowing in extend, anyone can pretty much extend this greeting interface. There is no way to limit this scope. But let's say I am developing a library and I want to limit a certain language. Let's say I want to limit to English and Arabic. That's two languages I support. I don't support any other language. But it's a library that I published. Now I have an interface over here. And basically now anyone can basically implement the user, or they can introduce another language, let's say Chinese, which I don't support right now, but they can implement create a Chinese greetings, and they can pass it and it will still work. Maybe it will break something inside, maybe it will not work properly, but basically it allows that. I cannot I don't have any way to control that in inheritance structure. That's why seal class really super helpful. So basically what we're going to do is, if you're a library developer, you will define interface as a sealed interface, and then you allow there is a clause called permit, and you only allow this to subclass. So now nobody will be able to inherit these greetings, and still I'm allowing inheritance, but it's more controlled environment. So that's basically sealed class provide, and I am super happy about that. For example, let's say in Java, um, you know, we have a string class, right? Let me go open this string class, and it's a final class. That means it closed the boundary of inheriting. No one can inherit string. Now, I mean, all the features of a string are into one class, compact with the different kind of parameters and everything. What if there is a possibility of two kind of strings? For example, to encode certain language, certain character. For example, Unicode, it requires, let's say, 4 byte of data, 4 byte of memory, right? 4 byte of data. And let's say English, which is pretty much ASCII value, right? It probably requires only one, byte. So we could have a two type of a string. But why they didn't allow that? Because the string has to be immutable, and there are certain security aspect in the string. So they don't want anyone to contaminate a string. But what if we had sealed this sealed inheritance, which is control inheritance? We could have multiple strings in the JDK, and still their control. As a developer, I wouldn't be able to contaminate any of those strings, but still there is a hierarchy. So sealed class basically that solve that problem. And yeah, so that's essentially it is. I have an example over here. So I have an interface which is expression. I wanted to create expression evaluators. I probably have that example over here. Maybe I can show you directly. Let's see. So this is the probably, yeah. So I have interface over here, which is expression, and it permits only these few implementations, because that's the only implementations I currently support. So uh, I have still the inheritance architecture, and interestingly, I can record can implement an interface. So that's basically goes make the whole thing more tight and simpler. As you can see over here, it go hand in hand, simple as an interface, and it's also allow us to do a pattern matching. Over here, you can see. I wanted to talk about pattern matching, but since the code is available here, let me go over with it quickly. So basically in Java now we have pattern matching. So these three things, scene class, records, and pattern matching go really hand in hand. As you can see, the whole thing, if I want to write earlier, all those things, I had to write like tons of lines of codes. But now I can just, for example, this one is basically one line, and four type of expression, I have like 4 lines of code. uh, Earlier I had to probably write way more code than this. And now pattern matching basically support in Java. We can pass in expressions, and based on type we can do certain actions. For example, if it's a constant expression, I can just return whatever it is. If it is a negative expression, I can evaluate by negative. It is a plus expression, I can add those two expressions, right? So something like that, and I can it's only 19 lines of course. And I did a similar experiment, same functionality, but with the traditional approach, I have to write like 70 plus lines of code. So contrast 70 lines and only 20 lines, and less verbose and less it's way more concise. Anyway, moving on. So there's a link over here, you can read it, that discuss the whole things. For example, record, and how C class basically you can create algebraic data type. I don't have much time, but that's why I'm going to skip it for now. But you can read it, basically, from this link. I'll share the slide with you all. Moving on, since I was discussing pattern matching, let's go over with this. So Java also introduced pattern matching. It was the one of the demanding feature from developers. All other programming languages like Scala, I don't know, Kotlin probably has some to some degree, and other programs like Ruby has this pattern matching feature, but Java didn't have. So finally we have this. It's basically simplifying programming patterns in much simpler way. It started with this. Basically, as you can see, when we do check instance of, we pretty much familiar with this feature, right? I mean, if access instance of string, then we can safely cast that. But the problem is, it could be a question. I mean, a simple question, right? If access instance of string, we know about that, why do I have to cast it again? So that's a additional line of code that we have to write. And initial pattern matching is stem from this thought process. So that can be transformed like this. We can directly create the variable over here, which is, if existence of a string, then str is the variable, and we can directly use that. Using that, we can definitely improve one. We can create a lot of expressions. For example, if x is a string and it has length greater than 3, we can do certain things, else we will do something else. Moving on, we can transform it into a Swiss expression as well. For example, if if it's a string, and when the string is greater than string's length is greater than 3, we can do certain things over here, and we can do a multiple, right? For example, multiple, we can create multiple case statements, something like that. So it makes code really tight and simpler. Moving on, there's another example over here where we can extend this switch expression way further. For example, if we get a value, we can check null. We can check whether it is a string, whether it's a different integer, whether it is an array. it could be a list, and it can be a part of a wrapper class. So for example, this value is a field of a wrapper class. We can also deconstruct that, which is basically over here, var. So I'm going a bit quickly over these features, but uh, that's the whole idea. And there is another interesting example that I really love. You can combine sleep class, pattern matching, and also records, three things together, and create a nice code out of it. I probably have example over here. Let me see if I can show you that examples. So yeah, so let's say I have options over here. Maybe I can open this one, right? Why it's allowing me? Anyway, so let's say I have an interface which is options. That means it's basically something like optional we have in our Java. Just I wanted to show a demo. So it has it can only two subtype, which is it will have value, otherwise it will not have value, right? Sum and none type. And over here you can be in the permanent statement, you can see it's allowed only two. And now we can create a method something like that. So if we pass a option emails, and we can do a switch operation on top of it. If it is done, then we can pass something else, which is no, we don't need this default over here probably. I don't know why it's asking defaults, but it's probably not required. Anyway, so basically we can combine these three things and make something really simpler and concise. So that's the powerful features Java has now. Moving on, let's see. I showed this example already, so I'm gonna move ahead. You can do algebraic data types combining all of those things. And in JDK, there are lots of new features coming, which is basically part of Project Embers. I will really discuss about cast, records, some of the pattern matching, and string template was one of the interesting features that I really loved, but for some reason they dropped in JDK 23. Hopefully they will bring it back. There's some issues going on. Hopefully they'll fix it and they'll again, start working on it. So let's skip that. There is another feature that I really love, which is unnamed variable and patterns. Let me show you an example over here. Somewhere over here. Okay. Before going that, if you have any questions, let me know. We can go take some questions, and then I basically go ahead with this new features.
Yeah, I think so far no questions.
Mm-hmm. Okay. If in that case I can continue. So let me open another example, not this one. So not this one as well. Okay, so let's stick with this this code over here. So we have a still interface, which is interaction, and it has comment, like, and share. Basically, it permits three subclass, and we have also user over here. And if we do use a I think I can find this quickly over here. Comment. Okay, so this is what it is. I'll have to comment it out because for some reason string template, like I said, a string template is not allowed anymore. So that's why it's not, I'm using JDK 23. String template is not available in JDK 23. That's why it's showing, giving me an error. But again, so let me. So we have this, class structure, and basically interface interaction. And interaction can be a form of comment, like, and share. Now let's say I have an interaction and I want to switch over on that interaction. It can be comment, it can be like, it can be share. But as you can see over here, when I'm going over a comment, I can deconstruct uh, the what do we say, record class over here. So I can I'm deconstructing over here the inside in the content of this comment, right? So comment has, like, user, content, and then optional timestamp. But for that particular cases, I'm only interested in two things, which is var, which is user and comment. I'm probably not interested in the timestamp. So if I deconstruct this, I will have this timestamp over here as well, right? But if I want to take certain action on this, I probably don't need this particular one. So what I can do is I can just ignore using the underscore, and it's a less noise now. So that's basically essentially this feature is about. Maybe I can give another concrete example. Let's say over here, I have a try catch, something like that, right? Now I don't want to I don't probably want to record these exceptions. So what I can do is I can just ignore this. It's much simpler. I could have another example, something like that. For example, for, let's say I have a list over here, and based on the item in the list, I'm not interested about content of the list. Let's say I want to do something, but over here, let's say print as a hello world. So if list has, like, 10 values, I want to print hello world 10 times. Sorry about that. Integer. Okay. But I'm not interested on this item itself, the content of list itself. So I can do underscore over here, something like that. So basically it's unnamed variable. I don't care about it. I can just ignore it. So those are really useful use cases of this particular features, and I really love it. So let's undo this because I have a interesting demo for this particular. Okay. So moving on, I mean, as you can see, I only interested in the particular variable that I'm interested in, and I can ignore others. The second one is I'm interested in comment only, so I can ignore first two. So this is really useful feature. I'm gonna ignore the string templates because it's stopped in JDK 23 for some reason I had in this slide. But yeah, I mean, it is one of the fascinating features that I'm really care about, and I was really excited about it. And all the other languages like other programming language has this string interpolation feature, but Java didn't had it. Now that it had, I mean, in JDK 22 you will have it, but 23 they dropped it. So that's a bummer. Anyway, there is another interesting feature. It's small features, but I really love it. So let's say I want to extend the big integer, right? And I have to call the constructor of superclass. So the only way we could do is super something like this, super, and then provide the value over here, because the restriction was it super has to be the first line of the constructor of derived class or subclass. You cannot run any code or before super. So that's the restriction we had. The problem with this particular scenario is if we want to throw exception over here, right? If it's a negative integer, we want to throw an exception, so it's not a valid argument. But this super is basically doing a lot of work already. Big integers constructor do assess this value and does certain things already. And after doing all of those things, I'm basically throwing in exceptions. That doesn't make sense, right? I'm working, and after working a while, I'm just disregarding the value. So now this is basically giving a bit of flexibility. We can now do this. So super can be called later. This is a small feature, but certainly powerful. So if long value is basically a negative number, you can throw an exception earlier, and then if it is passed, then you can call this super. So basically, you reduce the cost of processing. So that's super small, but super useful. Anyway, moving on. Okay, how much time do we have?
No problem, Bazra. We have time. No problem.
Okay, maybe if I can go a little bit over our designated time, would that be okay?
Yeah, sure, no problem.
Okay, perfect. So there's another interesting feature introduced in Java 16, which is called vector API. I'll probably gloss over it because it probably begs a whole presentation on it. So I'll just gloss over so that you can have a look on it. So the idea is, let me give you an example over here. So let's say I want to do a calculation right over here. I have a two array, integer a, integer b, and I can add them and put into this result. So over here, I did a for loop, right, which is basically from I to length a. All of this happen is one at a time. So one instruction at a time. So basically, if the array is huge, so it will take some times to calculate all of those results. So what vector API is doing is there is a thing called a certain computation, certain cross hardware provides single instruction multiple data, or SIMD capabilities. What it does is basically, let's say I want to add, but you can provide multiple set of data. Let's say I can do 8 addition at the same time. So basically, it's using the hardware capabilities and optimizing it, and making it faster. So that's what this essentially, from the very high level, vector API is. For this particular calculation, if you can do something like that. So what it does is basically, it can, let's say over here, this loop bound, the over here it's a called spaces. Spaces preferred. We have we have to go into this API. So the idea is, spaces basically how many data we can put in a single instruction. Let's say if it is 8, then it will add 8 value at the same time. So basically, it's basically parallel addition or parallel subtraction, or any sort of computation, something like that. So it can make your program way faster. So if you have a huge computations, you can definitely use this vector API that will make your computation way faster. So look at the vector APIs. It's a part of Project Valhalla, and yeah, I feel like you can extract some of the capabilities of modern hardware provides. Java didn't had this feature earlier. Now it has. So fascinating. Moving on. There is another really exciting features called foreign function and memory API. So what happens is there's some really great library available which are not Java. For example, OpenGL, some of the machine learning libraries are written in C++. those are really excellent, performant, and super useful. What if we want to use them from Java? I mean, we could write all of those using Java. Basically, you can rewrite library. That's a huge effort, right? Um, Not all of them are written in Java. I mean, there's a lot of machine learning library available in Java, but there are really excellent library available in C, C++. Why don't we use them, right? We can use their capabilities. The problem with this is, until now, Java didn't have a nice way to interact with native functions, native memory. Let's say we want to allocate some chunk of memory outside of the heap. We didn't have that options earlier. Now with this API, it's much simpler. I'll show you a demo for this, and you will see yourself how easy it is. So, I mean, we had some sort of API earlier, which is a byte buffer. It has limitation. For example, you can only, uh, you know, uh, it has only allowed 2 GB of memory outside of the heap. And then there is another API called unsafe API. A lot of controversy around this API. I mean, this API itself called it's unsafe. Don't use it, but people just keep on using it, and then controversy keep on unfolding. Anyway, so and there is other uh, functionality. For example, JNI. We have this has been for a long time. People use, but there's certain limitation of JNI. It's really buggy. It's really difficult to use. Maybe I can show you a quick demo that will show you how difficult it is. So let's say I want to do a quick sort, and this quick sort is written in C, and I want to use that. So this is the Java code that invoke native code, which is quick sort over here, right? So to achieve that, what I have to do is I have to first of all declare a method which is quick sort, which is a native method, and then load a library. So basically, this library is not available now. I have to create it first, and then I can call it. So the idea over here is I'm invoking a native method. It's written in C, C++, and I'm calling that method to sort these numbers. It's just an example. I mean, we could go in real life. We'll probably use more sophisticated code, but for the sake of demonstration, I just picked the quick sort. Okay, so what we have to do next? We have to compile it, and then I have to generate a header for this. So based on this quicksort JNI, I have to generate this header, which is quicksort JNI, and then I have to create class, quicksorter class. I mean, quicksorter C++ code that basically implements these methods, which is over here. This one is generated, like this function is generated. Now I have to implement it. That basically essentially called the native quicksorter. So that's what over here. And so this is the implementation. I'm not going in details, but this is the implementation of that. It essentially called the quicksort of native, which is this line. And now I have to make it a library, which is over here, live quicksort. So, and only then I'll be able to basically, invoke this functionality. So the problem is I had to go a lot of steps. And what if there is a inconsistency? There is a sync issue. What if the something changed, and we have to always keep on doing this, keep on doing this loop, and it's really if your application is complex, it's going to be a really difficult job. So I have a readme over here that basically explain what I have to do. So I can show you a demo over here. First of all, let me go into that location, JNI. So, and then I have to, maybe I'll remove all of those things. This is the only class I have. let me remove all of these things so that I can show you a demo. Okay, so this is the, I don't know why it's not allowing me to delete it, but never mind. So I have to first compile it. I have to compile it over here, and then I have to produce the header first, which is not here, right? You can see if I do run this, it will create a header, which is this basically, and then we have implementation. I have already written it, so I'm not doing that again. Now, based on this quicksort JNI, I have to create a library. So for it depends on the operating systems. For Mac, this is the command. So I have done it, right? So now it created a leave quicksort library, and now only then I can invoke these functions. So there is a different command for that, and as you can see, it's sorted. So it is using the native quick sorted library. What if we have a better way to do it? I don't have to go through all this scenario. I have only Java code. I have a stable API. I can just use them. So the front function and memory API is exactly that. So I don't have to go anywhere. I just have to write the Java code like this. I'm not going to explain it because it's definitely one begs a whole presentation of itself. So just have a quick look. It's an imperative code. Over here, I have a linker. First of all, then I have a lookup. This lookup basically looks up the, where this, quicksort function have. So I have using this method, I'm basically finding the memory address of memory segment of quicksort function, and then I have a description of that quicksort functions. Basically, all of them are imperative, and all of them are Java, essentially doing the same thing. And if I run it, I'm not going to explain whole things because it will take some times. Let me ignore this for now. As you can see, it does the same thing. It's essentially called the native quicksort function, but it's just Java code. So life is much easier now. Now let's say the reason Python is popular is basically Python can easily access some of the native library written in C++. And the reason Java is a bit lag behind because Java, there was no straight easier way to basically call those native library using Java functionality. I mean Java code. Now we have. So hopefully people will start using Java for their machine learnings, AI, and all sort of things now. Let's hope for the best. Anyway, so moving on. I mean, there is some APIs. I'm going to ignore it. I'm going to share this slides with you so you can definitely have a look at it. Here's an example, same example. It's a different examples, but similar. It's using Redis sort. The demo I showed, it was a quick sort. Similar things. And then finally, I'm going to gloss over it because this is a huge, development in Java. But if I can show you a quick demo, the idea is, high-level idea is, until now, Java had one way of doing concurrency, which is traditional threading, and traditional threading has certain limitations. For example, we couldn't have as many as we want because in operating system there is a limit how many thread we can create. If we can create many threads, that means we can have more concurrency in our applications, and more concurrency basically result higher throughput, right? So since we are limited by the number of threads we can create, we literally come up with the different alternative solutions. For example, we do thread pooling, and thread pooling is nice. It does solve certain problems, but also it introduce certain problem as well. For example, you have to tune the thread pool, right? You don't know how many thread really need in the pool, so you have to do sort of tune up. And the traditional threads has a limitation because Java doesn't have really a thread, right? It's basically a mapping of an operating system threads. So when you create a thread, you basically called native threads, and native threads are limited. So solving those problems, Java come up with a new revolutionary idea, which is called virtual thread. The idea is, it's a simplification of concurrency. You can have a lot of them. You can create many virtual thread as you want, and they're basically Java construct. They're not dependent. They're not native Java threads. So basically, you can create a million of them. They're like the regular Java object. So let me show you a quick demo if I can. Let's see if I have this. Not this one. Basically, I have all this example using string template, but unfortunately, I'm not showing the string template. That's that. Anyway, so maybe I can write a quick Java code over here that will show you the virtual thread demo. So PSPM. Now let's say I have a atomic. So what I'm gonna do over here, I'm gonna try to create how many thread we can create using the traditional approach, and then I'll show you the same demo using the virtual thread and how many virtual thread we can create. So that will give you an idea how easy to create virtual threads and how many of them we can create. So let's say so maybe I'll do while true thread t new thread. The GitHub autoflow is really annoying at certain points. So what I'm gonna keep a variable over here, which is atomic integer counter, new atomic integer. I'm gonna count. So increment. Probably that's not what I want. If counter get value. Okay, so what I did is, if so that it doesn't keep on printing on the console. So over here, t.start. So whatever here I'm doing is basically I'm creating a new thread, and then I'm incrementing a value, and if it reaches thousands, I'm gonna just printing, and then I'm parking that thread. Basically, the thread is created, and it will wait there and see how many thread we can create. As you can see over here, after creating 9,000 threads on this machine, I have got out of memory error, so unable to create native threads. Basically, that's a higher limit. That's the limit of amount of thread we can create in this machine. So same thing I can do with virtual thread. Creating virtual thread is easier. Of virtual started. So same thing. The API is extremely same. I mean, as a developer, when I'm using traditional thread and using virtual thread, there is not much difference, to be honest. Only a few lines of here and there, but the way we're going to approach this virtual thread is the same way we used to do. So we don't have to learn a lot of new things. Okay. So if I stop and run, as you can see, we were able to create millions of threads on fly, and it keeps on creating. The caveat is, these are all those threads resides in the heap. So basically, they're garbage collected part threads. So once they are done, they all get garbage collected, and we can create as many as we want on fly, and it takes splits of seconds. So that's the amazing part. So now let's say imagine we have a web applications, and we want to scale this application, right? with the traditional thread mechanism, we can have a thread pool, and number of thread pool is limited by the number of thread we can create on that machines. So let's say we can create only 1,000 threads in this pool. So if we want to get a higher throughput, the maximum could be thousands, right? But now that we have a virtual threads is practically, let's say, unlimited. Theoretically, there's some other consequences, but I don't want to discuss those things now. Now, let's say a server, in modern operating system can even handle millions of concurrent connections. So if we use the thread request per model traditionally, so we could in fact increase our throughput way higher, because since operating system allow a lot of connections to come, each connection we just hand over one connection to one virtual threads, and we can keep on creating virtual threads. So that's amazing. That's how we can increase the throughput. I mean, there are certain downside, there are certain limitations that we cannot do, but those we can discuss later. I'm in fact writing a book on modern concurrency. So probably I'm just once I'm done, you probably will be able to read all those things. I'm still writing. Just wanted to share that. Sorry about giving. Anyway, let's ignore. So there's another aspect, which is structure concurrency. This is a side project of virtual thread based on virtual threads. I'm probably gonna ignore it for now, because how much time we went over?
I think, how much time is left for you, Bazza? How many slides are left?
So if I ignore the structure concurrency, I don't have much. This is the last one, I guess.
Okay, no problem. Let's wrap it up. No problem with this. Yeah.
Okay. So yeah, I mean, so that's the amazing feature we have with the virtual threads. And structure concurrency is basically organizing the concurrency in a better way, which is going to be available. I mean, it's available as a preview feature, but will be available shortly. So maybe we'll have a presentation on only structured concurrency some days. Okay, so another thing is really exciting in JDK 23. I mean, it's available since JDK 22, I guess, which is launched multi-file source code program. The idea is you can write a script using Java. You can have a file, and then you can have basically you can definitely write single source file, something like that. Let me show you. So over here, hello world, right? You can definitely use you can run it using the terminal, but you definitely want to run this in a command line. So let me go into source. If you want to write a script, right? Let's say since we have now this easy main method, and we don't need even a class structure, something like that. We can. It's like a flat file, and we can keep on writing methods on top of it. Then we can definitely use it as a script as well. So if I want to run this, what I have to do, I can just copy this line, right? So since it's a preview feature, I'm gonna do this. So I can run, as you can see, it's run hello world. But what if we need a it's a one file, right? But what if I have to use class which is written in another places, which is over here, greetings, right? It's another class, but it's in the same locations, but in another class. So what we have to do initially, in previously we had to specify the location of that class, and we had to do basically we have to do a lot of work. Now we don't have to. We don't have to do anything. We can just use this, and we can use same command. As you can see, it's still using the same command. So basically, it can find the source graph I mean, if it is the same locations in the same parent file, it will be able to automatically find that class. You don't have to specify it. So that's the new features. And what if I want to use a library, right? I want to use a library which is JSON object over here, and this is available in a different locations, which is in the lib folder. What if I want to do that? It's also available now. Let me remove this. Maybe print string. So you just have to specify the library, and that's all. And you can use that. And as you can see, it uses the library. With this new feature, you probably don't have to use a build system anymore. So if you want to do a small experiment, quick feature, you don't have to rely on ID. If you have just JD installed machine and terminal, you can write any script and you can put your library in a folder, and you can specify. You can probably write a script out of it, bash script or something like that. You can do all sort of amazing things, and you don't have to install Maven or Gradle or something, all sort of complicated stuff. So this is the interesting feature that I really felt worth sharing. So all right, so that's all I had. I mean, I skipped a lot of content because of the time, but that's all I had. And now I'd like to ask this question: which among all of those features, which feature did you like most? You probably can share on your comment, and I definitely love to hear which one do you like. I personally like this combination, which is record sealed and uh, pattern matching. And obviously, virtual thread is another great feature. But if you want to just syntactical language feature wise, I would say those combination of three, which is sealed, class, and records and pattern matching. Those three I really like. And let me know if you have any questions. This
Yeah, I think the community also shared the same feelings. So personally, me, I really love the pattern matching. I wasn't really aware of it. It's really amazing. And also, there is another interesting feature, the virtual threads. I think people are really loving the virtual threads. There is a couple of questions, if you don't mind, Basler.
sure, go
So
ahead.
let me start from a little bit up, if you don't mind.
Sure.
There is someone who's asking, I'm curious to know if it is possible to override the main method and see what happens. So are we able to override the main method or?
So let's say if we have two main methods in this class, what would happen? That's the idea, right?
Yes.
That's the question. Let's say over here I have a main method. Sort. Sorry, I don't. I want to print a different message over here. Let's say hello, dear Jack. Okay. So now I have two main method over here. Now the question is which one would run. We can do just experiment, see which one it. I mean, there is definitely a priority. So let's see if we have this priority over here. Looks like it basically preferred this one. So
Yes,
is
the
it
old
because
style one.
yeah, is it because I wrote it first, or
Yes.
I don't know. Let's experiment that as well. So I moved that over here. And now if I run it, let's see what happens. Looks like
Yeah.
it's still preferred. So if we
Old
have
is gold.
a main method that takes argument, probably it will take the priority. So let me remove this public static, and let's see now which one it takes. So one would have it takes argument and another doesn't. So let's run it. So it's still basically the idea is if we have two main methods and one takes arguments and one doesn't, then it will take it will the one has argument will be prioritized. And what if we have a different, let's say, instead of string, let's say I have integer, then obviously this is not a main method anymore. It's a simple traditional method.
Yes.
If I run it, obviously it will run the first one.
Yeah, sure.
All right. So hope that answer your questions.
Yeah, it does really. There is another question, if you don't mind, Basil, sorry for
Sure,
taking your
sure,
time.
sure. No.
I think someone is asking about the code line completion. So, what's your opinion about this new feature about code line completion? I think the plugin that you're using,
Uh,
which is
sorry,
Copilot, I think.
can you repeat the question? I did not quite.
So I guess that the question is about what's your opinion about this code line completion? I think that you are using the code
Oh,
completion
okay. The
plugin.
the 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 automatic completion of code, that,
Yes.
yeah. So basically, it's a AI tool that I use, which is called GitHub Autopilot. So there's multiple tools available. One is Autopilot, and another is called JetBrains AI Assistance. The idea is basically uh, it's useful, especially when you are writing test code. Uh, you know, writing test unit tests, especially, there are a lot of repetitive stuff, right? So personally, I use GitHub Autopilot or JetBrains AI assistance for those cases. It's really useful. For some time, it's annoying. You could see that when I'm trying to write something, it spits something else, which is super annoying. But a lot of time it's useful. If you're writing the same type of code regularly, it's definitely going to save a lot of time, because it can now understand that these are the type of code you were typically write. So it will repeat the same type of code, um, and it will save a lot of times, basically. So let's say I can give you a quick example. um, I want to write a documentation. So as you can see, I just wrote double
Yeah,
slash,
it's
and
really
it's
smart.
speeding. So now I want to write a method, write a method, maybe not here, over here. I want to write a method that takes two dates and find the difference. So between days, probably if I start doing that, it will probably it will probably public int c. It's split the code, entire code. So it helps full sometimes.
Amazing.
And there are other useful cases, especially if you want to refactor certain codes. For example, you have a complex code, right? Maybe I can give you an example. I don't know if I have a good example over here. So let's say this code, right? It's basically a class called location tracker. I want to refactor it. I want to make it better. So what I can do is I can select this code, portion of code. So let me go up, and I can go into the GitHub chat. There is a GitHub Copilot chat, not this one, this one, and I can say simplify, or write a test, or explain, or write a documentation, or fix it. Let's say I want to fix it, improve the code. So it will read the code and give us some improvement. So as you can see, it says I have reviewed the selected code and it seemed to be well structured and readable. However, there's two methods, find cluster and find closest location, that are not implemented yet. If you want to improve that code, you could consider implementing this method. So basically, it implemented that method, right? So those are fascinating stuff. And now let's say I want to write a test, uh, you know, unit test for this class. So I can ask test. So it will try to write give me some unit tested code, so which I can directly use, and then improve upon it. Basically, it will speed a lot of code. As you can see, it's speeding a lot of codes based on these things. And yeah, so those are the kind of thing that I really loved. And I mean, those are probably not 100% accurate. Definitely still you need to have human oversight. I mean, but it will definitely reduce some of the toil.
That really sounds good. But the question is that do you recommend using this for production code?
I mean, obviously, I mean, I do use a lot in my day-to-day work, but again, I would say you have to have human oversight. Don't just blindly copy paste and use it in production. Rather, you know use it wisely. Basically, use it, look at it, really it's correct or not, and this is how we want. And then you can, if you see it fits your purpose and it looks okay, then you can definitely use them, right? Ultimately, it's on your hand. It's your decision, basically. So you will still need to know. You cannot blindly uh, depends on AI generated code.
Yeah, yeah, sounds good.
Human oversight is a must.
Yes, of course, of course. So we need to copy, paste, review. This is the
Definitely,
process.
you probably have to edit a lot. I mean,
Yeah, yeah, sure.
basically, it will give you a nice structure, which basically, uh, okay. So when we did not have had IDE, when we did not have IDE, how did we write codes? We code in a
Yeah,
text editor, and we had to write every little details. Now IDE, in fact, help us to automate a lot of things, right? Let's say I want to write a print statement, so I just write as out and put a tab, so it automatically write whole statement. So similarly, id has been helping in many ways. If I want to write for loop, it just automatically spit for loop, but still we have to provide the input over here, how long we want to use the for loop, right? So it generated certain line of codes, but as a developer I definitely have to look into that code, whether this fits into our needs. Same things for AI. It's going to help you. It will reduce some of the toil, but as a developer, you have to look into the code. You have to read the code and edit it, and it probably not 100% accurate. So you have to fix those areas, but don't rely blindly. So that's what I'm trying to say.
yeah, we'll say. There is another question about which version of Java is it possible to use this related memory API, I mean, to call the external native APIs or memory related stuff. So is this related?
Uh, Let me see. It's probably JDK 22. Um, JDK 22. Yes, it's released on JDK 22. So if you
Nice.
want to use JDK 22, you can use this. But it's also available in JDK 21. If you want to use JDK 21, you have to use preview feature. But it is shipped, delivered on 22. So if you want to use this foreign function API, use this. And this is the truth. Uh, Everything you want to know about foreign function API available this document. So I can share this in the chat as well.
Yeah, sure. Uh,
Mm,
let's see if there is, yeah, there is another question, I think, which is good. Uh, so comparing virtual threads and the reactive, reactive Java. So are they like completing each other, or the Loom project is replacement for the reactive framework, or how does it go from your?
That's definitely a great question. The answer is yes and no. Okay, so how? So I mean, okay. So let me answer this way. So initially, we have to first ask the question: what problem it's basically solving? The virtual thread. What problem it's solving, right? So we had a situation where we had a lot of blocking operations, especially, let's say, think about a web application, right? So if you start a request, you send a request to a server, it basically takes a thread from the thread pool, and then it start processing your request. So when it start processing your request, it has to do a certain things. For example, it might have to go to the database to fetch some data, and then it probably have to call some external services, right, to get some data, or do certain things. So let's say T1 is your initiative thread that started doing the work. So it will call database. Then let's say, it's super annoying. Then external services. So what happens is, while calling this database, right, it will take some times. Let's say it will take some 200 milliseconds. And then it will take another 300 milliseconds. So let's say total, I have to, if it is the same thread T1, it will it will take like 500 milliseconds, and it will also work on certain thing. For example, it will process and everything. Let's say in total it takes 600 milliseconds. And this thread, essentially, when it calls the database, it initiate the call and waiting for the result, and it's not doing anything. Whole time it's blocked, right? And then it call an external service. After calling the external service, it's waiting. It's not doing anything. So basically, entire whole journey in this whole journey, the 500 millisecond, this initiator thread is basically blocked, and it's not doing anything. So uh, since thread is limited, in traditionally, right, threads is limited resource. If we waste the resource like this, in total we are basically wasting a lot of time. So whole thread, all of those things are wasting our valuable resource while it's not doing anything. What if, while this database is call happening, we could improve this, right? We could improve doing this parallel. Now in total it will probably not take 500 milliseconds. Rather, it will initiate a call, first call, and it will wait on a future, and then we immediately call the second, dispatch the second call, which is external services. So now the amount of time this thread T1 is blocked is reduced. So that's an improvement. But again, it's still um, um, wasting some of this valuable time. Basically, it's still blocked a certain things. So reactive programming is basically try that we can solve this problem. We can make entire application in a way everything is unblocked, so that we have a limited number of thread, and we were going to use them all the time. So let's say we have in our machine, I have like um, I have like, let's say, 100 threads, and we're going to use them all the time so that they don't waste any of those times. So we're going to, when if there is a blocking operation, it will go from this. Let's say I'm in a thread, I'm executing a code, there's the blocking operation, I'm executing this block, it will go away from that execution, something else will come. That's how it's basically solved the problem, right? But the way it's solved, it takes a certain structure, certain understanding, certain learning, and it becomes difficult. And that way our human mind um, you know understand code, deal with code, we basically read line by line. But when the reactive programming, we write reactive programming, but the execution pattern is not exactly how we write code. It's completely different. Some of the bit of codes run in this particular thread, some of the bits of code run in another thread. So it's basically difficult to debug, difficult to reason about. But it's definitely solved those problem, initial problem, which is blocking problem, right? So that's the way of solving reactive programming. But virtual thread comes here and say, okay, you don't have to wrap your head with a you know with a huge learning curves. You don't have to learn functional programming, you don't have to learn reactive stack. Rather, the way we used to do, we'll do the same thing, but we'll create a plenty proliferation of threads. If a virtual thread is blocked, we don't care, we can just create another virtual threads. So and uh, the way it internally work is, we have a limited number of carrier threads. I mean, basically the operating system threads. If I see a blocking operation running on a virtual thread basically unmount from carrier threads. It reside in the heap, and the operating system thread pick on another virtual threads and they start executing. So the idea is, the way virtual threads implemented is, we can have a plenty, as many as thread we want, but system resource are always working. So limited number of threads are always working. That basically maximize the resource utilization. Again, keeping the traditional approach of imperative approach of programming intact. So if we want to go into virtual threads, we don't have to learn a lot of new things. The way we used to program imperatively line by line, it's the same. So both of them are trying to solve the same problem, but differently. Personally, I would say, if you are a developer which used to with the traditional way of programming, imperative way of programming, you can then you want to use the traditional debugging and all those tools, then you don't have to learn anything much, and you probably be more comfortable with virtual thread than reactive programming. So um, down the road, let's say next 5 years or 10 years, people will probably not use reactive programming for a new project. If there is an existing project which is already using reactive programming, then yes, that has to be maintained, right? But for a new project, people probably will start using virtual threads. So the answer is, both of them are trying to solve the same problem in different ways. If I have to choose, I would probably choose virtual threads because it's easier. I don't have to learn a lot of things. I'm already used to with the concurrency model, um, existing concurrency model. I just have to change a few line of code here and there, and it will work automatically out of the box. On the other hand, if I want to go reactive programming, then I have to go through a whole lot of new learnings. I have to learn a new way of writing programming. I have to learn functional programming, which is fine, but there are certain caveats in reactive programming as well. So and also it can easily go overcomplicated. Simple things, people start to use hammer for every nails. So when they learn uh, you know reactive programming, they start to use it everywhere, and that makes code base extremely complicated, extremely difficult to debug. So those are downside of the I would say reactive programmings. I hope I took
Yeah,
that answer your questions. Sorry, so for
yeah,
taking
yeah.
a
Yeah, sounds good. I think Basla, also reactive programming is a completely different stack, whereas the virtual thread is, maybe you can use it within that stack, because reactive programming is completely like, as we said, you have to use the whole journey as reactive. So you need to have it from beginning till end reactive. Otherwise,
Yes.
it will like affect
Yeah.
the
Yeah.
whole the whole journey.
Right.
So I think yes, the comparison here is way different than this one. Yeah, I think there is no more question. I think we are. I think no questions from the audience. If you have anything to add, Mr. Puzzler, you are most welcome. If you want to end the session.
Um, First of all, I mean, thank you for inviting me, and I'm honored. Hopefully, in future, I'll be able to visit in person to
Sure,
Jag, uh, and meet all of those all of you in person. That will be an awesome experience. Looking forward to
sure,
do that. And if you have more questions, if you want to reach later, then you can use these two links over here that I'm sharing. You can reach. I'm pretty active in Twitter and LinkedIn. So if you have questions, you can just DM me or send questions in LinkedIn. So I'll definitely try to answer your questions. And there is also um, a newsletter that I started writing. I don't write frequently, but I write sometimes. So if you want to, get some insight what I'm doing, what kind of technology I'm excited about, you can definitely find in this, the Coding Cafe newsletter. It's a LinkedIn newsletter. You can definitely take use the QR code basically to find that. Yeah, that's all I had. Thank you.
thank you so much, Puzzler, for this amazing session. Really,